Hello students, welcome to the today's lesson. Today we will learn F-test. In the previous lesson we had seen the student's t-test and today we learn F-test. So this test uses the variance ratio to test the significance of differences between two sampled variances. So F-test, this is based on the F distribution, is called so in the honor of the great statistician Professor R.A. Fisher. Let's consider that there are two samples with the observation values x1, x2 and so on till xn for the first sample and y1, y2 and so on till yn for the second sample. And these are the values of two independent random samples drawn from the normal population with some variance. This is the variance. So now first thing we'll do is we'll define the null hypothesis. The null hypothesis H0 that the variance of both the samples are same. So that means population variances are equal of the two samples. Now under this null hypothesis, we have to calculate the test statistic for the F test, and that is capital F given by S1 square upon S2 square, where S1 has to be greater than S2. So the formula for the S1 square, this is 1 upon N1, where N1 is the sample size for the first sample. 1 upon N1 minus 1, and then sigma, the sum of xi minus x bar. X bar is the mean of this first sample. So xi minus x bar whole square. Similarly, the formula for the S2 will be 1 upon N2, where N2 is the sample size of the second sample, and then the sum of the summation of the yj minus y bar. Again, y bar is the sample mean for the second sample. Now we can get the degree of freedom v1 and v2. v1 is equal to n1 minus 1 for the first sample, and v2 will be n2 minus 1 for the second sample. We have to take care that the greater variance among the two variances are always taken into the numerator, and then the smaller one will taken into the denominator. So let's see what is the procedure for the F test. So the step 1, we will set the null hypothesis that the independent estimates of common population variance do not differ significantly. Then we'll find the degree of freedom v1 and v2. The third step, we'll calculate the variances of the two samples given with the formula S1 and S2, and then we'll calculate the F test statistic, that is capital F. Now from F distribution table, we will get the tabulated values of this V1 and V2 for the degree of freedom till the desired level of significance. Normally we used to take it at 5% level in significance, or we can take it at 1% level of significance. And the last step is to compare the calculated value of F with the tabulated value of F to the desired level of significance. Now if the calculated value is less than the tabulated value, then definitely the null hypothesis will be accepted. So the null hypothesis will be accepted, and we'll say that the population are with the same variance, they do not differ. So let's see what are the assumptions for the F test. One is both the populations are normal populations, samples have been drawn on random basis, observations are independent of each other, and no measurement error is there. So we'll take these assumptions for the F test. Now let's go ahead and calculate the perform the F test on this example. So let's see, this is example. In one sample of size 8, the sum of squares of deviations of the sample values from the sample mean 84.4, and in the other sample of size 10, it is 102.6. Test whether the difference is significant at 5% level of significance or not. So we can see here for the first sample, the sample size is given 8. For the second sample, the sample size is given 10. And now we already have the deviation of the sample values from the sample mean. So we have sigma x minus x bar square, which is 84.4 for the first sample. And for the second sample, it is 102.6. So now we can directly calculate S1 square, which is 1 upon N1 minus 1 sigma of Xi minus X bar whole square. So we have this value, we have N1. So this is 1 upon 7 into 84.4 coming 12.057. Then S2 square, this is 1 upon N2. N2 is 10 and this is giving 102.6. So this is coming 11.4, which is greater from these two. So this is greater. This will be into the numerator. So now we'll calculate the F statistic, keeping the larger value into the numerator. So this is 12.057 divided by 11.4 comes to be 1.057. Now the last step is the comparison of this value from the tabulated value. Now we can see degree of first sample, freedom, that is 7. Degree of freedom, and for the second sample this is 9, n1 minus 1, and here this is n2 minus 1. So this is 7 and 9, and at 5% level of significance the tabulated value is 3.29. And now we can see as the calculated value 1.057 is less than the tabulated value. That means the null hypothesis is accepted, and we'll say that there is no significant difference in the variance of the two samples. Now let's see this with one more example. Okay, now let's see this example. Here the two samples are drawn from two normal populations. So this was the assumption for the F test. From the following data, test whether the two samples have the same variance at 5% level of significance. So this is sample number 1. We have the sample size 1, 2, 3, 4, 5, 6, 7, 8. So for the first, the sample size is 8, and for the second, the sample size is 10. So now we will check. So let's calculate first the mean of the first sample and mean of the second sample. So just to get the mean of the first sample, as we know, the formula for the mean is sigma of x upon n1. Here sigma of x we can get from the first column by just summing all these values 60, 65, 71. So it's coming 600. So mean for the first sample is 600 divided by sample size, that is 8. It's coming 75. Similarly, mean for the second sample. So we'll get the sum of all the values by summing up this 61, 66 and so on. So this is coming 770. And now we can calculate the mean by 770 divided by the sample size. This is 10. It's coming 77. Now using this mean, we can get the deviations from the mean. So now for the first sample, we can see the mean is coming 75. So this is 60 minus 75 is coming minus of 15. And then again 65 minus 75 is coming minus of 10. And similar way we can calculate this column. Now we'll get the squares of these means. So 15 square is equal to 225, 10 square is 100, 4 square is 16 and so on. So we will get this squares of the deviations for the sample 1. Now for the sample 2, we can see that the mean is 77. So this deviation will be 61 minus 77. It's coming minus 16. Then 66 minus 77. It's coming minus of 11. Now on squaring these values, we will get the squares of the deviations. That is minus 16 square, it's coming 256. 11 square is coming 121. 10 square is coming 100 and so on. And now we'll sum these values. So we'll get the sum of the second sample. This is 1200 and this is coming 636. Now we'll be using the formulas and we'll calculate the S1 square. This is 1 upon N1 minus 1. We have calculated this. We know what is the sample size. So this is 7, 636 coming 90.857. Similarly, we'll calculate S2 square. N2, we know this is 10 and we have already calculated this is coming 1200. So this is coming 133.33. Now we can see that the larger value is 133.33. Using this, we'll calculate F. We know that the larger value is always into the numerator part. So we'll get 133.333 divided by 90.857 coming to be 1.467. Now we need to get the tabulated value at 5% level of significance for freedom of degree. This is 9 and 7. So now this is coming 3.68. And now as we can see that the calculated value 1.467 is less than the tabulated value 3.68 and hence null hypothesis is accepted. and we can say that there is no difference in the variances, or we can see that the variance are same for the two given samples. So that's it for the today's lesson. We learned another test, chi-square test, in the upcoming lessons. Till then, goodbye and thank you so much.